Hello friends, I am Jatin Joshi and today we are going to explore the fascinating world of rational number. Ready to master some maths magic? Let's jump in it. So friends, this is an introductory video. In this video lecture, we basically learn about all the things which will helpful in solving our questions in the exercises. So let's start from the small an introduction. What we are going to cover in this video lecture. First of all, we'll discuss about some basic things like first, natural number, whole number, integers, then our rational numbers, and then their rational numbers, properties, first closure, associative, third commutative. And then we'll do next finding rational number between two numbers. Next, representation of rational number on number line. These all things we will going to study in our upcoming video lectures. So now in this video lecture we will overview these topics. So let's start. First, natural number. What are the natural numbers? In our previous classes we have all studied about natural number. Natural number are a set of numbers starting from 1 counting up to infinite. Set of natural numbers is denoted as n. What is mean? Numbers start from 1 and goes up to infinite are called natural numbers. 1 and goes to infinite are called natural number denoted by n. Next, whole number. Whole number is a set of numbers starting from 0. It means we can say this is basically natural number plus 0. Means the numbers which start from 0 and goes up to infinite are called whole number, and these numbers are denoted by W. Integers. What are the integers? Integers are basically natural numbers and their negatives and denoted by Z and I. Z or I. And we can simply say that we start from negative integer, negative infinite to positive infinite. Means you start from negative infinite and goes up to positive infinite. The representation may be negative infinite dash 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 -2 -1, and we include that 0 or is a middle point. 1, 2, 3 goes up to positive infinity. Here we can say that natural number or whole number. Okay. Integers, in a simple term, integers are natural numbers and their negatives. The set of integers is denoted as Z or 0. Next, our point, our topic, rational number. What are rational numbers? Any number. A rational number is a number that can be represented as a fraction of two integers in the form of P upon Q, where Q must be non-zero. Means you know that what are the integers? Integers from negative infinite to positive infinite, including 0 also. Okay. And rational numbers are numbers which can be represented as form of p upon q, where q is not equals to 0. P and q both are belongs to integers. Means they both are integers. Means I can write minus 4 by 3 it is a rational number because both of the numbers are integers. Can I write a natural number like 3 in the form of p upon 2? Yes, I can write it in the form of p upon 2, and that's why I can say it a rational number. Means if you can represent any number in a form of p upon q, you can say that that number is a rational number. You should remember that q is not equals to 0. Why are we saying this? Because if 0 is the position of denominator, it means whatever value is on the numerator, it doesn't matter. It is not defined. It is not defined. So let's jump to next properties of rational number. We will study about 3 properties of rational number in this chapter. First, closure property. Second, commutative property. And the third one, the last, associative property. First of all, closure property. What is the closure property? For any two rational numbers a and b, a operation b is equals to c belongs to q, which means both the a and b are rational numbers and their operation of anything like star, the operation, whatever between them, like was plus, minus, and multiply. Closure property is applicable only for these three, not for the division. We will study after short time. Means for any two numbers like a and b, both are rational numbers, and an operation from positive from addition, subtraction, and multiplication, we can choose anything like, and as the universal symbol is star, a star b is equals to c, which belongs to q. It means the answer, the result from the operation is also a rational number. For two rational numbers, say that a and b, the result of addition, subtraction, and multiplication operation give a rational number. Give a rational number. Means closure property is for addition, subtraction, and multiplication. I can do it by I'm saying this. Means the question is what? A operation B is equals to C, it belongs to Q. Means rational number. For first of all, for addition, I'll choose minus 3 by 2 plus, sorry. We'll choose 3 by 2 plus 1 by 3. Means we get the LCM of 6. And here 3 3s are 9 plus 2, which is equal to 11 by 6. And this is a rational number. Yes, it is a rational number. And also A and B also are rational numbers. Yes, it is rational number. Then for the next subtraction, I am taking both the two numbers which I have taken previous in addition. Like 3 by 2 minus 1 by 3. LCM is the same. The numbers were also same. but the symbols are changed. It means 9 minus 2, 7 by 6. This is also a rational number. Okay, and it means here also A and B are integers and sorry, A and B are rational number, and the answer is also a rational number. We'll see this for multiplication. Means 3 by 2 multiply 1 by 3. We get 1 by 2, which is also a rational number. It means closure property is applicable for addition, subtraction, and multiplication in rational numbers. So why are we not choosing the division? Because of some restrictions like here in the case with the division. In the case with the division of two rational numbers, we see that for a rational number a divided by 0 is not defined. Hence, we can say that the closure property does not apply for some rational number in the case of division. It means the closure property is only applicable for addition, subtraction, and multiplication. And what is the closure property? A operation B sorry A operation B equals to C. A, B, and C are rational numbers. All of three are rational numbers. This is the closure property. Next one is commutative property. For two rational numbers A and B, A operation B, B operation A, that is commutative property is 1, where the result of an equation must remain the same despite the change in the order of the offense. If you change the positions, means if you put B at the place of A and A at the place of B, if the answer will not change, if the answer not change, it means it follows the commutative property. Like we'll take an example. 3 plus 2 is 5. 2 plus 3 equals to 5. And the rational number 1 by 2 plus 1 by 3 is equal to 5 by 6. 1 by 3 plus 1 by 2, which is equals to 6. 2 plus 3, which is equal to 5 by 6. Again, both the results are same. Despite their positions, the answer is remain the same. Let's see for the subtraction also. Minus 2 by 3, 1 by 2 minus 1 by 3, which is equals to 3 minus 2 by 6, which is equal to 1 by 6. Here is 1 by 3 minus 1 by 2. 6, we get here 2 minus 3, and the answer is minus 1 by 6. The results are different. It means commutative property is not applicable for rational numbers for subtraction. Let's see for the multiplication also. 1 by 2 multiply 1 by 3 is equals to 1 by 6, and 1 by 3 multiply 1 by 2 is equals to 1 by 6. These are the same answers. It means commutative property is one where the result of a equation must remain the same despite a change in the order of operations. Commutative property means results remain the same change in the order of quaternions. The next associative property. Associative means A star B star C is equals to A star B star C. This is likely commutative property. For any three rational number A, B, and C, associative property is one where the result of an equation remains the same despite the change in the order of their occurrence. They are our friends, and this is applicable only for addition and multiplication. This is not applicable for subtraction and division. We'll say why. We have this question for addition. 1 by 2 plus 1 by 3 plus 1 by 4 is equals according to the equation 1 by 2 plus 1 by 3 plus 1 by 4. 6 5 by 6 plus 1 by 4 equals to 1 by 2 plus 12 here 4 plus 3 5 by 6 is 24 and I would say 24 here 20 plus 6 20 plus 6 and here 12 plus 14. Here it means 26 by 24. Here also is 26 by 24. Now the results are the same. Now we'll see for subtraction. 1 by 2 minus 1 by 3 minus 1 by 4. And here which is side 1 by 2 minus 1 by 3 minus 1 by 4. That's in the same 6, 3 minus 2 minus 1 by 4, 1 by 2 minus 0 by 7, 4 minus 1, sorry, 4 minus 3. Here we get 1 by 6 minus 1 by 4. And here 1 by 2 minus 1 by 12. No, not 24, sorry. 12. 12 here 2 minus 3 and here 12 and 6 minus 1. Here we get minus 1 by 12. Here we get 5 by 12. These are not same. It means subtraction. In the subtraction, associative property for rational number is not applicable in the subtraction. And we all know that for multiplication in multiplication, if we change their positions, it will not affect their answers. Okay. That's all for today. Please